Right, hello everyone. This is a talk about code review, not anything to do with Composer best practices. My name's Dave Liddament. I have been working in various software, including PHP, for about 15 years. And for most of that time, or for at least half of that time, I've been using code review with various tools like Gerrit and GitHub and Bitbucket. I also run with a couple of others a small software consultancy called Bristol, and we also mandate on all our projects that we use code review as well. And the reason we do that is because it's the most effective way we found for developing software. When I'm not working, I help organise user groups in the UK. So if you're ever over in Bristol, do check us out. There's PHP Southwest and Bristol PHP training. And as we'll discover in a minute, when I'm not doing coding, I am a keen scuba diver. And before we talk any more about code review, I'm just going to talk a bit about cave diving. That's a picture of me in a cave in France. I don't know how well that's come out, but the cave itself is beautiful. And the kind of cave diving I do, I always dive in a team. There's normally at least one other person, sometimes two. And there's lots of benefits of diving in a team. We can chat about the great dive afterwards. That was a fantastic dive. Did you see that? But probably the biggest thing is the redundancy that team members offer. So if something catastrophic happens to my air supply, I can borrow my buddy's air. If all my torches fail, I can borrow my buddy's torches. But probably the biggest bit of redundancy we have is a spare brain. Because while kit failure happens very rarely, humans, as we discovered in the first talk, make mistakes all the time. No one's perfect. So I'm going to tell you about one of my mistakes. So one of the procedures, cave diving used to be really dangerous, now that's pretty safe. And one of the reasons for that is that now, wherever we are in a cave, we always have a line that takes us, there's always a line from wherever we are in a cave back to safety. And sometimes we're going along our line and the cave kind of breaks into two and we get to a T-junction. So there's a line, and this is called a T. And when we get to the T, we need to remember that when we're coming back, which way safety is. So what we do is we put a marker on the line called a cookie. That's a navigational cookie, and we always place it exit side. So it means we can go off and look at other things, and then when we come back, we know that the exit's over there, and we don't go off somewhere scary over that way. So we kind of get out alive rather than further into the cave and possible death. One day, I was in a cave, got to a T-junction, and I put the cookie in the wrong place. So if we had just continued going on with our dive, we'd come over here, and then we'd come back to the T-junction, I wouldn't have known what to do. Which way is safety, and which way is trouble? Of course, we don't want to get into that situation, so what happens is, the moment I was here, and I put the cookie in the wrong place, my teammate signaled to me and said, Dave, you put the cookie in the wrong place. I corrected it, put it in the right place, and we went on with our dive. So the moral of that story is we all make mistakes. Even really simple things that if we get wrong could have pretty serious consequences. However, if these mistakes are spotted and rectified quickly, then the consequences of those mistakes can be minimized. So the moment my teammate saw that I put the cookie in the wrong place, he corrected me. And we also want to make mistakes really, really easy to spot. And this kind of feeds in quite nicely with what they said in the keynote. So that's cave diving. What has all this got to do about software development? Well, we all make mistakes. The sooner we rectify the mistakes, the consequences of those are minimized, and we want to make our mistakes as easy to spot as possible. So you've probably seen graphs like this. This is the cost of a bug. The longer into the software development cycle it is, or the longer it festers in the code base, generally the greater cost that bug is. So we want to take a bug that's really expensive and pull it down here to where it's cheap to do. And code review helps us do that. In fact, effective code review reduces the overall cost of software development. So the agenda for the rest of the talk, that's why we're here. We've discussed why. We're going to look quickly at code quality. We're going to look at the benefits of code review, and we're going to see how we can implement it. And I'll give you some tips that I've learned along the way. And finally, we'll see how we can quickly set up GitHub to enable code review on all your projects. So code review doesn't sit on its own. It really works best with a few other things. First of all, we need tests. Doesn't matter how we test our code, we just need automated tests. We also need stuff that looks at our code and can do some basic analysis on it. You know, is our code adhering to whatever coding standards we've set? We might want more complex static analysis as well. And then finally, we need something like a continuous integration server that takes care of all this kind of stuff. So when you get new code pushed up, it will go and run the tests. It will run whatever static analysis we're doing, and it reports whether that's successful or not. So all talks need a Wikipedia quote. What is code review? So code review is the systematic examination of source code, and it is intended to find mistakes overlooked in software development, improving the overall quality of the software. So how can we do our code review? We could be working in teams and doing pair programming, and that's kind of like real-time code review, two people working on the same bit of code at the same time, correcting each other as they go along. But what I'm going to talk to more about today is using tools like GitHub, or seeing how we can use a process more like GitHub for this. And I've been using GitHub, or Bitbucket, or Gerrit predominantly for the last 7 or so years. So that's what it is. If you sort of said to people, what are the reasons we might do code review? Probably the number one reason they'll say is we will find defects. And the question is, what kind of defects will we find? So we've got bugs. So if you think bugs as defects that will, if executed, they will cause the code to fail. And that's traditionally what we're thinking about bugs here. However, there's a whole other set of bugs which are called evolvability bugs. And I'll define an evolvability bug is a code that makes the code base less compliant with standards, more error-prone, or more difficult to modify, extend, or understand. Because often with our code, we start in one place and then we keep adding to it. And the interesting thing about evolvability bugs versus like our traditional bugs, if you like, is studies have looked at this and see what proportion of defects are raised in code review. And actually, our traditional bugs, things that actually cause the code to fail, don't actually account for that many, maybe only 20%. I've got links to these studies, and they're on the slide at the end. So evolvability bugs count for the majority of the defects found. So even if we had perfect tests that found every single traditional bug, if you like, we've still got a whole load of defects that are of interest, these evolvability ones. And you might say, well, why does this matter? Why is evolvability important? And again, the studies have looked at this, and they've said low evolvability code costs money, basically, and there are some stats they found. So new features took 28% longer to implement. Finding bugs took 36% longer. And these are big numbers. So if we can cut out some of this, it will drastically reduce the cost of our software development. And kind of how does this manifest itself? All of us who've kind of worked on projects over a long time, if we think about how long it takes to develop similar-sized features in code that's riddled with technical debt and difficult to understand, the similar-sized features just take longer and longer to develop. So it ramps up quite quickly. Whereas if we've got clean code, high evolvability code, then actually the cost is pretty much constant throughout time. So that's why these things are important, certainly if you've got ongoing projects that are going to last a long time. So I think it's quite an important takeaway, because when you start doing code review, you might just think we're just interested in finding bugs, things that stop the code from executing, things that if executed, the code will fail. But in reality, we are going to find some of those, but it's actually these evolvability bugs that will probably make up the most of the defects we find. And actually, I've certainly agree with that as well. Most of the defects we raise in code review are things like, I think we can do this better because the code will be cleaner, and so on and so forth. And this is important because if we need to sell this concept to management, make sure we're capturing the right data. If we're only reporting bugs, that cause the code to fail, that might only be 20% of the total bugs that you actually find. Okay, so another benefit of code review, there's 5 benefits we're going to go through. Finding defects was the first. Second one is security review. So first one's pretty unlikely, but maybe somebody's computer got compromised. There's some file that's not supposed to be there, and they've accidentally added it up, and they pushed it up. So if you see files that aren't supposed to be there, do query them. What is this exe file, what I've got there that's not supposed to be there? Now, I actually wrote this slide about a month ago, and the reason I picked out the writing sensitive data to logs is because that's something that I'd done inadvertently. I'd left some debug in, which if somebody, I think, used the wrong password, it would end up in the log file if we were at debug level. And I thought no one would be silly enough to log, sensitive data like passwords to files. But I thought I've done it, so maybe someone else did. And about last week, I got an email from Twitter saying they'd also done something similar. So apart from me and Twitter, I'm sure no one else does that either. We want to think about stuff like the OS top 10 as well. There's a great cheat sheet, so Google OS top 10 cheat sheets. That's a whole topic in itself. I'm not gonna discuss it much now, but do look into that. There's quite a few things that we can only really find by manual inspection of the code. And then there might be other security no-nos. People might not be hashing passwords, or they might be using MD5. I think there's a talk later on today about sodium, so look at that kind of stuff. And in fact, just generally anything to do with people trying to roll their own authentication or hashing or encryption algorithms. If they're trying to do stuff like this, I would advise them to make sure they're looking at a proper package that does these kind of things. So these are things we might spot in manual inspection that we can't really automate. So a third real benefit of code review is it spreads the knowledge between the code base. So I found this really useful. I could be working on a bit of code here, but I can still see what's going on over there and there and there. And that's really useful because I might see things that people are doing and say, oh, you two need to have a chat with each other because you're doing something very similar. Or I might say, look, I've already implemented some code that does something similar, so why don't you have a look at what I've written? And it keeps everyone aware of what's going on in the whole project, even if they're largely focusing on one bit. So we can kind of move away from silos. We don't have Romeo's bit of code here and Juliet's bit of code here, and they don't want to look at each other's bits of code. They can work together on the code. So we get rid of silos. And that's great because if Juliet wants to go on holiday, she can go on holiday, and she doesn't have to worry about it because Romeo knows all about Juliet's code, and if something happens, he can help fix it while she's enjoying herself in the sun. And in terms of business benefits, I mean, this is all business benefits anyway, but we're increasing the bus factor. So have people heard the bus factor? So the bus factor is how many people you'd have to run over for your project or your company to fail. So a bus factor of 1 is pretty bad because that means one person gets run over, the project stops, or the company fails. So code review offers us the ability to up our bus factor. So if we have a bus factor of 2, that means obviously we need 2 people to get run over by buses or equivalent before bad things happen. So if Romeo got run over by a bus or drank some poison, we're fine as long as Juliet is still okay. So a fourth benefit is mentoring. It really helps having people who maybe are junior developers. They get to see how more senior developers develop code, and hopefully they're developing code in a better way. So they pick up from that experience. But also, senior developers can see if junior developers are maybe going down the wrong path, and you can come along and they can come along and help guide them. And I've definitely been on projects where it is really beneficial getting, it's really benefited the junior developers having their code reviewed, even if they didn't feel like that at the time. It's also a great way of getting new people onboarded onto the project as well. So if you've got someone who might be relatively experienced but have no idea about the project or the domain that they're working in, the code review, the mentoring helps get them on board. And the reason this is important from a business perspective is that the more experienced people are, the rate at which they put bugs into code decreases. And experience isn't just years worked, it could be general coding experience, it could be time on the project, it could be time using a particular technology. And the final benefit is essentially you're being watched, and people kind of modify their behavior slightly when they know they're being watched. And I've certainly found this on projects where we've kind of turned code review on. It just feels as though there's like a jump in quality because everyone knows that their code will be viewed by their peers quite close, before it actually can go live. I couldn't really find any studies that back this up in terms of coding, but there was a study done it was on the UK police, but replicated around the world. And they put cameras on the police, and then they looked at how many complaints there were against the police from one year to the next. And it reduced by 93%. It was an incredible difference. And that's not just because the police are misbehaving, it's because the people they're videoing kind of up there, be better as well. So those are kind of like the 5 benefits. We can reduce defects, and studies back this up. We find security vulnerabilities. We can spread the knowledge and help people get up to speed. And of course, that kind of peer pressure, knowing that the person sitting next to you or working with you on project is actually going to look at your code, often does up everyone's game. So I kind of said this right near the start, and I hope everyone kind of agrees with this statement now. And if we're all on board with it, let's look at some of the details in how we can implement it. So the first thing we need to do is automate everything we possibly can. We don't want to waste human time on things that computers can do because computer time is far cheaper, even when we consider how long it takes to get these things set up. So the kind of things I would be expecting us to automate, we want all our tests. We definitely want our code style, so things like PHP, CS Fixer are quite useful for this. So they will check, you can set it up, whatever your coding standards are, and it will go through and check that your project adheres to those. Linting is also pretty useful, so it can check the PHP is correct. But there's also things for YAML and Twig and Doctrine. I think Symfony offers checkers for all of those. Even just your composer validate, run that part of CI, so you know that your JSON and .loc files are valid and in step with each other. You might want to do more advanced static analysis. Those kind of tools do the kind of static analysis that PHP Storm does for you. Some of those static analysis things you've got to be careful because you'll get false positives. And we want all the stuff that we automate to have minimal false positives. We also want to think about doing third-party security checkers. So the Sensio Lab security checker, that looks at your composer files, and it works out what packages are being used, and if anyone has raised a security vulnerability against one of those, it will report that. So these are all the things that we automate, and we don't even get to the manual step until all of these things pass. So by the time we're here, we know everything's worked, all our tests pass. So the first question, I think the most important question we can ask is, are the tests doing the right thing? So if we look at our story, our requirements, and we look at our tests, are they actually doing the same thing? Because if they're not, then we need to flag that in code review. And if we think back to our cave example with the cookie, One of the reasons this worked is because it's really obvious that a mistake had been made. And tests are a bit like that. Tests are generally far easier to understand than the code they're testing. So we set up our test, we say, this is our start condition, we're going to do this, and this is what I expect at the end. And that's generally far easier for us as humans to understand compared to actually trying to work out what the code is actually doing and work out if it's doing the right thing. So we might say, well, look, that test isn't correct. We would then send it back, and then the author would go, oh, yeah, I'll go and fix the test, which might then mean that the test breaks because the functionality isn't correct, and they go and fix the functionality. And this is, so you've indirectly found, a bug. But unless you're very careful about recording it, you might not know that that's what you've actually done. So this is another reason why you might not find as many bugs as you would imagine. It's because, the test will catch a lot of those. So yeah, are the tests doing the right thing? And even if the tests are doing the right thing, are they adequate? Have they covered everything? Have they covered the happy path? Have they covered all of the common failure cases? So if we've got an example test here, so here we are, I'm going into the cave, I come up to the T-junction, and before I pass the T-junction, I've got to put a cookie on the line. So that's all correct. That is absolutely correct. But it's missing a critical thing. The cookie has to be placed on the exit side. So again, when we're looking at our tests, we're saying, are these complete? And if they're not, we need to raise that as an issue. We can also look at things we are testing. So quiz time here. What's the minimum number of tests we would need to cover this? The absolute minimum. Any advances on none? Someone say 3? 3? Yeah, I'd go with 3. We need at least 3. So this is allowed method, returns a Boolean. So we want to do something where it returns true, something where it returns false. And if we look in the dot block, we can see it throws an exception. So we want to do something that makes it throw an exception. And depending on what is allowed does, there might be many more tests that are required. But these are the kind of things we look at the code and go, have we actually covered everything off? So that's the first thing. Are the tests correct? Another big question is, will I understand this code in 6 months' time? And again, it's kind of also alluded to in the keynote we had. You might write your code and think, I know exactly what I'm doing here. And just because you're so, your head is so in that problem space and you really understand what's going on. But someone else might come along who isn't quite in that same space, and they've got, I don't really know what's going on here. So raise that as an issue. And, what talk essentially about code quality, they will need a quote from Uncle Bob. So here he is telling us that the amount of time from reading to writing is 10 to 1, at least 10 to 1. So we spend so much longer reading code than writing code. So the benefit of making our code easy to read will mean that it makes it easier to write and then speed up development. So another quiz time. What on earth does this code do? Yeah. It's basically transferring data from one object to another, which is the same as this code does. You can probably work out what this code does pretty quickly. So this is a lot more boring. Sure, it's not as clever as what we saw on the previous screen, but we can look at this and go, yeah, I can kind of see what's going on. Whereas that previous one, that was, you got it quite quick. Sometimes people are looking at that code for ages. I remember looking at the previous slide for ages going, I don't really know what this is doing. So again, if we see code that might be a bit too clever and you're really struggling with it, then I'd definitely pick that up as a code viewpoint because everyone else will find it difficult as well. So another real example, we had an object called location and it represented a town or a city. And we had a method on it which was getURL, and the documentation that went with it wasn't particularly useful. It said string URL, as you can see. What on earth is a URL for a town or a city? I don't know. It could be anything. So if we have stuff like this, I'd query it and say, look, I don't really know what URL is for a location. It doesn't really make sense. I can understand first name on a person or last name on a person, but URL on a location, not sure. So your challenge is to go home, find some code you wrote 6 months ago, and look for things like this and say, do I actually know what all these things are? Because you might have known at that time, but you might not know now. So the first step is, could you suggest something that makes it more understandable? And the next thing is, you probably just need a comment there. So another kind of thing that maybe is worth picking up, what does this do? What is one? What does one mean? So if you see code like this, I would flag it up and say, come on, we need a constant just to add meaning to this code. How can we make this code more obvious? So we've got a marketing campaign, and it has a method add address. Well, address could be anything. It could be a postal address, it could be an email address. So again, we could say, well, let's make this a bit more obvious. Let's update it, say it's email address. Let's put a comment in to explain what add address really does. Is the fact we're adding this email address, and then at some stage later, we'll send them some kind of marketing. Maybe really could do more. We could say, look, there's missing type hints. We can add in those type hints. And then if we're using email address lot, well, maybe at an architectural level, we should think about having a value object that represents an email address. And again, hopefully, that this code at the end is a lot easier to understand or a lot clearer than it was at the start. So these are the kind of things we need to pick up in code review. And these are all evolvability defects. So another question is are we following project conventions? So each project will probably have their own thing. So if we look at all these method names, do any jump out as odd? The most find by. And then we've got search for location. So maybe there is a difference between find and search, or maybe people are using terms interchangeably, and this is the kind of discussion you often have. Are we finding things? Are we getting things? Are we searching for things? Are we locating things? And maybe there is a difference between search and find. But in this case, they just use search when really it should have been find. And what we do is when you start doing code review, you get a lot more of these kind of questions. So we started off a Slack channel called Coding Standards, and we would start each comment with saying this is what we're going to do on this project, and then in thread we would discuss why we were going to do it, or if there was any debate on that. And you don't have to use Slack, you use whatever you like. I mean, eventually you get quite established set of conventions, and you can pull them off and put them in a document somewhere, Google Doc or whatever else. But if you introduce if you introduce code review, you'll find you get a lot of discussions like this. So it is worth documenting them so that they're all there, and then you can use them on future projects as well. Another pretty important one is do the comments match the code? So this is obviously when the code's written, hopefully the comments match up, but more so when code is edited, when functions are edited or classes are edited, we then need to go back and make sure that the comments are still valid for whatever is going on there. Another kind of question I'd use is, has defensive coding been used? It's a kind of thing that static analysis can't really help us out with just yet. So we've got this set status method, and if we look in the dot block, it's saying that status can only really be one of started, finished, or quit. So if I saw code like this, I'd probably raise a comment on that saying, I think we need some check in the set status to make sure that we are trying to set it to one of the valid statuses. Some kind of assertion, maybe. Naming is really difficult. It's one of the two difficult things in software. And there's a couple of sources where we might get our names from. So the language for the domain of whatever we're using. So for example, if on a project I'm using, we've kind of got these things which we use interchangeably, like hunts and trails and games. And actually, some people call trails hunts, and some people call hunts games, and it all gets really, really confusing. So we've got fixed terminology. They should be games, or they should be trails. And we need to make sure that in all the code, we're referring to them by the correct thing, by the correct name, and in the comments, we're referring to them by the correct name. So whatever is specific to our domain, which hopefully we've documented somewhere, when we're talking about something, we should be using that exact term so as not to confuse things, especially in 6 months' time when people will be a bit more confused about blurring of these things. The second thing is stuff like design patterns. If you built something that is a factory and you don't call it a factory, then maybe you would pick up something and say, look, this is basically acting as the factory design pattern, so maybe we should call it something factory, because that has meaning to other developers who are familiar with those kind of design patterns. And equally, if you call something a factory, which isn't a factory according to the design patterns, then again I'd pick up on that because it will just confuse people. Somebody might see a person factory and assume that that is something that generates that builds person objects. And these are the kind of things which you need humans to double check and correct if need be. Potentially controversial, this one. Has technical debt been documented? There are times, I think, where you have to introduce some kind of technical debt to a project, as much as you don't want to. So a real example I had was we were developing some software, and if we could release it by the start of November, we would pick up all the Christmas sales. And that was huge. That was like by far their biggest revenue for the year. Now, if I waited until the code was like technically perfect, we might not be able to release it till middle of December or even January. So a decision was taken. We said, fine, we're going to deliver this early. We're going to put a few hacky bits of code that will need fixing in the long run. And because we put these hacks in, there is a chance that there might be a few failures, so we might have to reimburse people money, might have to compensate people. But we looked at the cost, the additional tech cost of doing it wrong and then fixing it, and we had a rough guess at whether we'd have to pay out for people when the games went wrong. And we decided that actually it was worth the risk because the Christmas sales were worth so much. Now, if we are going to put technical debt in code, we need to clearly document it. So we have a rule that if you have to do comments, it has to have a corresponding link. In our case, we use Trello, but whatever your ticketing system is. So the benefit of this is quite a few reasons. One, it gives a note to other people looking at the code. This is a genuine hack. We have knowingly added this technical debt in. We've also got a link back to a Trello card or whatever, so that is documented somewhere, and we can see, and then like management have a view on what all our technical debt is. So if I saw something that looked suspicious and there was no to do, or I saw to do and there was no reference back to a card, I would pick that up in code review. We don't really want to do this, but sometimes we have to. Kind of a bigger question. Can the architecture be improved? So I like things like solid be a guide for this. Are these methods doing more than one thing? Is this stuff at the right level of abstraction, and so on and so forth? And of course, don't forget to check if there are actually any bugs. You might still find some, but it's as in bugs that stop the operational software. But if you're doing all these other things and you're doing all your tests, you don't often find bugs. So that's the complete checklist. If you are just starting out, it's probably worth making your own checklist. If you've got new people coming on board, it's probably working with them to come up with a checklist. I mean, by all means, use this as a starting point. But it boils down to these three things, basically. Are the tests correct? Is the code relatively clean? And are there no bugs in it? Okay, so here's some things, tips I kind of picked up on the way. First of all, who should do code review? I think everyone in the team should do code review. Anyone should be able to review anyone else's code. We had a system whereby generally, because we're quite a small team, so generally it's just one person is all that's required for the code review. But we had a system where if somebody looked at it and thought, this is quite complicated, or I don't really understand it, it's not really my bit of the project, I'll ask someone else to do it as well. So normally you just need one person, but occasionally people say, I think this requires another set of eyes on it. And how big should our code that we review? If we give someone a small bit of code, they'll find loads of issues with it. But if you give them a huge bit of code, they'll just say, yeah, that's all fine. So if you've got some dodgy code, put it in a massive commit, yeah. So ideally, our commits should be small, just a single commit. But in reality, a lot of features are built up of multiple commits. And what we want to do here is let the commits tell a story. So first of all, we're going to deprecate something. Then we're going to add the new implementation. And then we're going to update the old code to talk to the new code. And then finally, we are going to remove our deprecated code. So our commits kind of tell a story. And this means when we're reviewing each commit, we know what we're doing. So it's just like methods and classes. They should focus on one thing. If you use Git, then interactive rebase is your friend to help you make your commits a bit more like this. And generally, we start all our commits with something like deprecate, add, update, and remove, just so you know what's going on, refactor. So how much code should be reviewed in one go? There was a study by SmartBear, and they looked at review done by Cisco, and they came up with these conclusions that essentially no more than 400 lines of code at a time. Certainly don't review any more than 500 lines of code per hour, and max 1 hour of review at a time. And what they found is the number of defects, like it was kind of like fell off at a cliff edge after those limits, the amount of defects that people found. So what makes a good commit? Well, it'll be small. It'll focus on one thing. If you've got like loads of white space changes to make, then try and make that as an own commit, just so you don't want white space changes in with functional changes because it's very hard to see it all. And whatever you're doing, link it back, reference things like what story is this to do with? What bug report is this fixing? What Trello card or Jira card are we using? So do link back there because then it gives context to people when they're coming to review it later. So what makes a good review comment? Don't be needy, don't be rude to people. Don't attack the author, even if they've made the same mistake several times. Just point out what the problem is and state the problem and state a solution. So what I really don't like in a code review is someone that says that name isn't very good. Probably the author knows the name isn't very good, so come up with a possible solution. I don't like this name, have you thought about this other name? And maybe the combination of those will get people come up with an even better name. Also, if we are specifying solutions, the chances are someone else has already had the same problem and the same solution. So rather than spending hours typing it all up, if there's a quick link you can just put in, just say, wrong level of abstraction, see this blog, see this Stack Overflow thing. Just to save your time than writing something that somebody else has already written once. Sometimes I say things like, let's chat. If I look at this and think, I could spend an hour writing a comment about this, it'll actually just be quicker to say, we need to schedule like 5 minutes just to chat through this. And that's often useful. I also sometimes start things with question, and the implication there is, I think there's nothing that needs to be done here. I think what you've done is correct, but actually it's my knowledge that's lacking, or I didn't really understand that clever DevOps thing you've put in the Ansible script. Can you tell me a bit more about that? So it's kind of spreading the knowledge. And also, if somebody's done something great, then just say, yeah, I like that. Thank you very much. We've had that problem for ages. I'm glad you finally sorted that bug out. So if we are receiving comments, again, be nice, don't be rude. And I suppose, don't take offense. Like if the comment just said .blog question mark, you could go, .blog question mark, whatever. Or you could say, actually, I haven't put a .blog there. It's a valid thing. I'll go and fix that. I mean, obviously, if people are really rude, then you probably can take offense, but hopefully people aren't, because they've abided by the stuff we said in the previous slide. But if they say something, don't blindly follow it. Maybe they're wrong. So sometimes it starts a discussion. Somebody's picked something up and I've said, actually, no, I think I am right. And then we have a bit of a discussion about it, and then we reach some consensus. And then maybe that's helped both of us understand whatever the problem we're trying to solve. And again, I've done this. When people have found some stuff, some really obscure bug, I'm like, oh, I'm really pleased you saw that. I would never have seen that. Well done for spotting that. So, Our code review tips. We want to get everyone involved, keep those commits small, make sure we reference whatever card or story we're working on, and be constructive in both giving and receiving comments. So, we've seen the value of it, we've seen how to do it, how can we implement it into our process? What we really want to do is to only deploy code where the continuous integration passes and everyone signed it off on code review. So imagine we're doing this in GitHub. We want to click on, and this might change from time to time, but we go to the branches, so we go to the settings, we click branches, and then we choose a protected branch. So we're going to say, we might say master branch is the only branch we're ever going to deploy. So we go into here, and we first of all tick the box that says, I want to make sure that I want to protect this branch. So that means we can't push to it directly. We will make pull requests, and the pull requests is the only way we can update things in master. So the first thing we do is you say, we want to make sure that the pull request can only go into master if it's been signed off, if review have said, yeah, we're happy with that. Then this is quite an important one, which they only added quite recently, actually, about a year ago. So suppose somebody had, the author had pushed some code up, it's all been signed off. If they push some more code up, we want to say, well, that's no longer signed off because there's some new code that somebody has to look at. So make sure that that box is ticked. We also want to require that our branch is up to date. So if we branched off master with our feature branch or our pull request, and subsequently somebody else has put some new code in, we need to merge that code into our branch before we know it's safe to merge back into master. And that enforces that tick box there. And finally, hopefully we're using CI, so we can say, look, these are called, I think they're called status checks. So you tick that box. Initially, if you've never run CI, it'll say there aren't any, but the moment you run your Jenkins or your Circle or your Travis, there'll be a tick box there for you to go back and tick. And then we've set it up. We basically have our master branch as a protected branch, and it's done all the things we've discussed today. So it's really simple. I've showed you GitHub. It's equally simple in Bitbucket, and there are many other tools which can do this. The tools aren't important, it's just the process. So there's not really any excuse to not start using this today. So in summary, this is what we've covered. We've talked about why it's so important. We've talked about some of the benefits, how to implement it, and we've shown you how we can just update GitHub if you're using GitHub to involve all this in there. So in summary, basically, code review reduces costs because we've got fewer bugs, because our code is cleaner, which allows us to develop new code quicker. It also helps us get everyone skilled up quickly on the project, which again is good. It reduces the rate that bugs get introduced. And tools today mean you can do this really quickly. It's not difficult anymore. And when we are reviewing, what are we looking for? We're looking for security problems. We want to make sure that all the tests are doing the right thing. We want to make sure that our code is relatively clean and that there aren't any bugs. So hopefully we're all in agreement that effective code review reduces the overall cost of software development. Thank you for listening.